Good morning to all of you. Thanks for this opportunity. What I'm planning to do here in the next 10 to 15 minutes is to set the stage for what we call as machines and space. That's a topic that's very catchily made over here for this NPC. I'm Satya Chakravarthy, Professor of Aerospace Engineering and heading the National Center for Combustion R&D at IIT Madras. That's a cap that I'm wearing today. So you want to actually look at the entire space tech value chain. Here is the big picture. So what we normally call as the upstream segment of the value chain is actually the launch services, the launch pad, the ground segment, which is beginning to talk to the launch vehicle as such that is getting launched, as well as the satellites. So that is actually on the left-hand side. The satellites themselves actually are what I would call as the mid segment. And there is like a plethora of applications that satellites are actually bringing in today. The most important of which would be remote sensing and communication. We will actually look at lots of other interesting applications as well, like in-orbit missions and new age space applications. This could be, for example, data storage or data transfer and so on from space, or lots of other applications like manufacturing in space. This could be drugs, this could be fiber optic cables, lots of this zero gravity manufacturing that happens. There is like a lot of space entertainment that is possible. Then there is, of course, space tourism. All of these things will, as far as the launch vehicle is concerned, is just satellites. That means that we just take something up to space. So it's essentially providing space access and space payloads. Then question is, what do we do with all of that stuff? And that is actually the downstream segment. The downstream segment is extremely cash rich. In fact, the interesting thing is, if you think that space is all about rockets, think again. Space is all about, actually, if you want to actually work where the money is, it's all the downstream segments. So there is data processing, insights and analytics, where you have like a large number of applications. We will go over them in a little bit more detail. And this is all where actually there is the value chain actually gets richer and richer and richer as you go downstream. So the upstream and the midstream segments are actually smaller when compared to the downstream segment. So as I was just beginning to talk about the kind of applications that you have, they are actually myriad applications. And I'm just focusing in this particular slide only on Earth observation satellites, but not necessarily limited to. For example, defense and security and a lot of other things could actually get help from communication satellites and lots of other variations of those payloads. But fundamentally, you have real estate, agriculture, mining and energy, supply chain, utilities, finance and insurance, defense and security, maritime, forestry, disaster management, and so on. The reason why I actually went through these to read for you, even though the icons are there, is because this will be a recurring thing that you will see in these many slides, because unless we are actually focused on the applications, there is really no point launching a rocket. There is no point in launching a satellite. We have to essentially serve these end customers. So what is the customer pipeline? So you have on this side, you have the left-hand side is essentially a set of, let's say, satellite companies. Like Pixel would be there, Galaxy would be there, ISI, Satellogic, Digital Globe, Airbus, Planet, Capella Space. So all these are typically satellite companies. What do? Right? They exactly serve a bunch of end customers. This would be like data refineries. These are a bunch of different companies that actually exemplify that. On the other hand, you have a lot of enterprises that partake of what the space offerings are from these satellites. And you also have a bunch of different platforms and marketplaces that are emerging that utilize the space assets. And that's how they actually feed the end customers that we saw in the previous slide. So what are the typical type of spacecrafts? And I'm leading to a particular theme here for India. So we want to actually have a big picture view of where what fits. So there is like a large range of satellite sizes in terms of mass, if you will, and correspondingly they would also cost. Right, so you now see the vertical axis is on the bottom is actually about cost, and the horizontal axis is about the size, and you can see a band of satellites that actually can serve these different purposes that we've been talking about. And what are these kinds of launch vehicles that are there that can take these kinds of different satellites of different sizes and masses? is on the left hand side, if you will. If you see, it's about less than 250 kgs. There is like about a handful of those. And between 250 kgs payload and 1000 kgs, you have again half a dozen or so around the world, and greater than 1000 kgs, you have a few, right? And these are the large players that SpaceX or Arianespace or ISRO, or those that we actually are more familiar with. A lot of these other ones are actually emerging in the space. As a matter of fact, ISRO has actually sort of looked downward to get into this mid segment range of 250 to 1000 kgs by making their a small satellite launch vehicle as well, right? Now, where do we launch from? And that's an amazing thing to think about. There are about, I mean, as of a couple of years ago, Bryce actually had put up about 77 launch ports that are available. Each of these has certain nuanced offerings in terms of access to specific orbits, inclinations, and so on. So in India itself, actually, you have marked about 4 of them. And by the end of this presentation, what I would like to actually say is that these dots need not be exactly where they are. You should be able to actually push these dots to wherever they are. Now, I told you that there is like a lot of money in there, and for the downstream segment when compared to the upstream and so on. So just look at the space tech investing in about a couple of years ago, how the trends were in 2017, 2018, 2019. I'm not looking at the recent ones because 2020, 2021 have been years that are sort of aberration, but we can actually get the drift in how the trends are in normal years by looking at the data here. So that specifically, you have to actually look at these numbers that are marking the change. You can see things like the total investment increasing about 39%, 70%. No, the numbers are actually very, very high. So the number of recipients, if you look at it, there is increase in the number of recipients of these investments as well, and so on. There are a large number of different companies that are doing this, and there are different sectors that are doing this, and all of that stuff. So there's like a pan sector investment that has been growing in good years. The outlook by some measures have been about the entire market would be about 20 to 25 billion in the next 2 to 4 years, 2023, 2025. There are more and more fresh assessments that are being made. In this, of course, so far, about 60% of them would be about government satellites, about 32% would be commercial satellites. Then there are many of them actually for the low Earth orbits, about greater than 100 kgs, and then 0 to 100 kgs would be about the commercial satellites, as a thin sliver there. So now, just want to focus on the small satellites itself, just to give a sense of what this is. Because if you actually focus on the small segment, you know how big the bigger segments. I mean, you can imagine how big the bigger segments could be. So today, the market is actually about close to $2 billion per year for the small satellites, when you're looking at somewhere between 30 to 300 kgs, that kind of segment. And you have like large number of different applications that I was talking about. Now, by 2025, this itself could actually become like 4 billion. So 2023 was 20 billion total. 25 would be 25 billion total, of which about 4 billion would be the small satellites itself. Now, no marks for guessing. Most of those satellites would be the communication Earth observation that's been the preserved so far. But you also see a large number of other applications like IoT and science and research and other applications growing over time, as estimated over here. Now, I told you that the downstream market is actually much bigger than this. So, and that's what this basically tells you. There are so many different sectors, and I read out all these different sectors, right? So, asset monitoring, supply chain sustainability, smart cities and urban planning, security and safety, precision agriculture, pipeline monitoring, the reason why forestry. So all of these things, the reason why I read out is because each of them actually is sitting with certain $1 billion worth of business to be done over here, and that's what this particular picture captures, and probably this conveys what I was trying to say. The interesting thing about space tech is it's actually a negative working capital business. You actually get about 95% of your launch price at T-minus 6 months prior to launch, and that makes it quite lucrative. And this is a business that, for all the reasons that I have mentioned so far, as well as this one, makes it very important for us to get into. However, there are these bottlenecks that we have on launches that typically happen. we can see that there are lots of these reasons over here, as well as the reason on the side where the satellite and the primary payload is the one that actually causes delays for ride sharing of other smaller satellites and so on. So together, actually, 75% of all launches are delayed due to the way the launch service is constructed. So the rocket people are actually this men who are actually saying, this is the rocket, take it or leave it, do whatever you want with it. That's not how the way the business is supposed to work. We need to actually customize the rocket to the different payloads, and that is the shift in the paradigm that we are trying to look at. So the shift is essentially about going towards constellation of smaller satellites when compared to having like one large satellite. For example, a cartosat may have a 6.65 meter resolution, but a 10-kilometer swath with a revisit of about every 4 days, whereas we can actually try to make this much smaller revisit times with a constellation of smaller satellites with about 2 to 3 meter resolution and much wider swath. So you can actually have a much bigger coverage and so on. So for example, a Planet Labs Dow 1 constellation of about 28 nanosatellites, each of them weighing about only 5.8 kgs and 100 mm by 100 mm. It's very, very small, right? So that's the satellite, how it looks like. You can actually hold it in your on your palm, and the kind of imagery that it actually gets is so breathtaking. So what are these kinds of sensors that are there? Getting into like a little bit of tech is there are optical sensors, and then there are synthetic aperture radar sensors, which are the optical sensors are rich in information because you get like a lot of color information, but about 3/4 of the time they're not available. For most of night they are not available, and when it's cloudy it's not available. Whereas with the SAR, you actually have only a grayscale information, where you have it's poor information, but it's available all the time, pretty much. So the emerging value adds are in two ways. One is it possible for us to actually focus on specific applications where you can use either optical alone or SAR alone, or the other one is to actually also look at a lot of other applications where a data fusion between these two sensors might help. And here again, you can see all these different applications that we have mentioned before coming up for different kinds of targeting the sensors for. Similarly, it's also important for us to actually look at how quickly can you actually get these satellites up and going versus what will be the frequency of the data capture itself once the satellites are up there. And here again, in this particular set of quadrants, you can position these different applications. And so this way of slicing and dicing can allow you to figure out like which market segment you want to get into with what kind of ammunition that you have in terms of tech. Similarly, on the launch side, we are going towards nimble and agile launching with what's called as 3D printed rockets, where even literally thousands of welds and joints can actually be replaced by just no joints at all in a single piece with like hundreds of parts that are just built together completely. And similarly, as I was pointing out, there are 77 launch pads with 4 of them in India identified. But if you actually have a mobile launching opportunity, you pretty much need only a barren piece of land. You don't need to necessarily develop launch infrastructure. Together with all of these things, the policy is actually something that we cannot understate at all. And the advent of in-space is actually something that is of a great boon in India starting May of 2020, that when it is announced. And I think the entire the apparatus is actually in place for moving forward with taking ISRO's support by the private industry when they want to launch or make satellites and put them out there and reap the benefits of it and so on. So there is like significant push that is the government is giving. So to conclude, my overarching thoughts about these are, first, space tech is actually now witnessing the next level moment at the moment. So we want to actually capture this and be very clear about this. More than SpaceX. So SpaceX is something that has actually made space like a mantra, but it's actually the advent of the small launchers that is easing the game for everyone. We have seen a couple of instances in the last few slides about how having smaller launchers and smaller satellites can make it more nimble and so on. So the real space tech actually lies in its applications. It's not about the rockets and the satellites. It's about like what do you do with them. And for this to thrive, we need to actually have access to space, and we have to actually figure out what we are really putting out there in space. And that's why it should be application driven, and the whole launch configuration and the satellite configuration should tailor to these different applications in a very nimble manner. So the convergence of 3D printing, composites, batteries and motors fueled by the electric vehicles revolution there, VLSI, cameras, deep learning, etc., is making this new space era possible. And it's never been a better time for space tech in India because of the policy push that has been given. And with this, we can actually become what I would call as a spaceport for launching, as well as space portal for accessing everything from space for the entire world. And we have a natural advantage on space tech because of the pedigree that ISRO has developed over several decades and been fairly impeccable in what they have been doing. So, along with drones, EVs, solar, semiconductors, and hydrogen, space tech is actually a big ticket item that India should be focusing on, and it's doing so. So, these are about a half a dozen big tech stuff that we should be pushing, of which space tech is one of those. So this is the moment for India's youth to seize the global leadership on space tech with small sats and launchers. Just focus on what you can do, but do it in a larger scale in terms of not just big rockets, but do large number of small rockets, large number of small satellites, and so on. And that is what is going to actually reap us the benefits and the leadership that we can come on. Thank you very much for your attention.